Start recording. Okay. Hello everyone. Okay. So I work at a company called Expert Analytics, as noted about 1 hour ago. I wish I can talk about all the cool things I did there. Right now I'm sitting out of Radium Hospital and I'm modeling, I'm basically mathematically modeling the cell and how the cell operates, and we're trying to use this to do some cool cancer research stuff. But because of non-disclosure agreements, I can't really talk that much about details of what's going on there. So instead, I thought I will talk a little bit more on code and how to get code into production. As in, I used to be an academic. I used to be in the position that Simon is. But these days, it's been 3 years now, I've been working in companies. I've been done with the university a while now. And instead, I work on production code. I use code that goes through versioning and all of these big code bases. Well, it could have been bigger since we don't have legacy. There are code bases that are kind of much, much larger than I have ever worked on. But still, they get big. And you kind of code in a style that tries to reduce as much complexity as possible. So I have a set of tools that I use while I'm programming, although I'm going to make an application now, but it's going to be dead simple, but it gives you a feel of how the formalities around it. I'm going to touch a little based on what I did with the PyTest, with the doc test module as well. So first things first, we need to create a module. I don't know if you guys have done this before. But let's kind of see, let's say pancakes. No, we make a source, and we make a source pancakes. And in your classic Python styles, we're going to make a couple of files in it, just saying that, hey, we're making a file, and then let's call it execute. In execute, we make a function, declare love, and it's going to print out a text that says something about I love pancakes. Something like that. Very, very simple. This is my application. This is my whole application right now. It's not very complicated. We're going to make it into an installable. So I made the folder source, and inside source I made pancakes. That was deliberate. I'm going to make a file called setup.py. Now, I've cheated a little bit here by creating the structure from scratch, but if you go into something called setup tools, how many here are familiar with setup tools? A lot of you guys. You guys haven't been using this in assignments, so you know this. You create your name, you create your package. Now there's something called find package. You used this before? Yeah. So you know the best practice when it comes to creating your tool. So this is very straightforward. And then, yeah, I need to ask a question for every single part, so I'm kind of jump over stuff that you already know. Okay, pip env. Are people familiar with pip env? Now we got into the blank stuff. So unfortunately, it's a little bit of a problem. pipenv got a bug last week, so I need to get around it. So there's going to be a lot of error messages on my screen trying to do this. Hopefully not, but it might be. It was that at least on Sunday when I tried this. But when you guys create your code, you either do it on your system, as in straight towards the hardware, which is highly, highly not recommended, or you create some kind of virtual environment. Have you guys created virtual environments before? Some of you have. Okay, not everybody. So this will be completely new. So this is idiomatic how Python wants you to create Python code. You install a tool called pipenv. Now, if you're going to do this, for example, on a Linux system, you can do just sudo apt. No, it's not sudo actually. It's sudo -h pip install pip env, something like that. There's a bug here. Like that. And you will have it installed in your system. Now, pipenv is both a way of managing dependencies, but it's also a way of creating a virtual environment. So if I say pipenv install, it will create a virtual environment. You can put a lot of default arguments and stuff like that. But in this case, I've set up my flags to create a Python 3.6.5, the newest version that I have on my laptop. I set a flag that I wanted locally, but usually it doesn't set it locally. So you can see that home, my user, source, pancakes, and then it creates a folder .venv. So in my folder now, there's a venv. This is not default, but I want to have it like this. You guys can see what this folder is. This is your virtual environment folder. Inside this virtual environment folder, it contains everything you need to run a full instance of Python. So basically, it's a copy of Python. So it's a lightweight container system. It's a copy, and you can have multiple of these. So inside your, for example, your bin folder, as you would expect, you have things that you need. You have pip, you have Python, which is, well, you don't really need much more than pip and Python. Those are the two tools you need. But just so you guys know what's going on, there's also something called activate, which allows you to activate your virtual environment. And most bash sessions will then give you some kind of indicator saying that, hey, if you activate, then you're in a virtual environment. Now, the old way of doing it is to source that activate, but in pipenv, you can do something else. You can say pipenv shell. And then suddenly, you're now in, and basically what it says what command it ran, /home then bin activate. So that's the command that you need to remember. And now I'm inside that kind of virtual environment. And I can do stuff like pip install, for example, pytest. Pytest, you know, or IPython. Oh, and if I now say exit and go out of this virtual environment, then if I say, first of all, IPython, I don't have IPython. Why don't I have IPython? Well, because it's inside the virtual environment. And I just went out of my virtual environment. But if I say pip and shell again, I jump in. I have my colored marker there. And I say IPython. IPython is there. And I can import pytest. So the idea is that if you are working on 7 different projects, have 7 different virtual environments. Have many virtual environments. But virtual environments are your little kind of easy to create, easy to destroy type of systems that allows you to not break your machines if you do something stupid, because we're human, we're all stupid. We do dumb things. Now, did I remember to, I don't remember. Let's say inside the virtual environment, I can now do install. Wait, are you guys familiar with the develop command? Ish. So instead of doing install, let's do develop. I'm going to talk a little bit in a second why I just did develop, but for all intents and purposes right now, it's the same as install. Now, if I now do IPython, I can say from pancakes dot execute import, I think it's declare love, and I can run declare love because it's installed in the system. This is familiar. This shouldn't be that complicated. Now, getting into things again. Well, this might need some kind of test. So let's create a doc test. This is repeat from the last lecture in a sense, that I just say the characters for saying that this is a Python interpreter, and if I say declare love, something like that, then I'm just going to do like this. This is what comes out. Now, since I'm in my shell, I have pytest. I can run it against the execute, and nothing happens. There's no test. So the thing that I did last time is that I did doc test module, like that. And suddenly I have a test, and it passed. So the idea here, if I remove this character, for example, and run it again, now it crashes. It expects that when I run declare love, which I think is typed incorrectly, but doesn't matter, and I got something with an exclamation mark. So basically I have my miniature tests, and I have a lot of these miniature tests. They are lovely because not only does it give you an automatic kind of tests that are local to the code that you have, because you want to keep your tests close to your code, but also it becomes so much easier to read, because you can see the intent of what you're trying to do a lot easier when your code is companioned with some examples of this is how you use it. Give a few words, explain what's going on. The example is usually more important than the text of explaining why you're doing it. Show is the best way of learning as a programmer. It's typically kind of the rule of thumb. So let's make this program a little bit more complicated. So we're going to say food item, and we're going to default it to pancakes, and then we're going to match this out with food item. So basically what I did is parameterize it. Are you familiar with the F string? Okay. So I'm learning you guys some new stuff. F is Python 3.6 only. So this doesn't work with Python 3.5. So if you guys don't want to upgrade to 3.6, that's fine. You can just use the dot format. But it basically does the same thing as, it's kind of equivalent to dot format and then ** vars, which is basically your full namespace. So the namespace is your n. So when you say, I would imagine this is kind of self-explanatory what's going on here, but I'm taking food item and just inserting it straight into the text. And this is an expression, so it evaluates it in real time. It's really recommended to do it this way, simply because it's readable. As in, you say, hey, you shouldn't put bars and put things into structure. But when you do raw texts and just insert it straight in, it's much easier just like, hey, I have a text now, just put your item, kind of your things that you want to print out straight into it. You're going to love it after you use it like 3 or 4 times and realize, why did I do it the old way? It's amazing. Now, if I now run the PyTest again, it passes. But let's make another test and say pineapple. Now I love pineapples, which is not what we want. Something like that. Now we have 2 tests for testing 2 different things. But I'm going to remove this a little bit, and I'm going to do something completely different. If food item equals pineapple, print no one likes pineapples, and then return. Doctest module passes. Now, one tool is testing. You have to write your own tests. But when you get to large type of projects, the danger of what you're doing is not really the code that you've tested and making sure the test works. That's good. But that just kind of sets a part of your imagination of this is how the code is supposed to work. This is how what I will test. So in a sense, you're limited by your imagination of making sure that you test everything. So there are other tools. And one of those tools are called coverage, PyCoverage. And there is a baked-in version. Just clearing out here. And I say pip install. Actually, I'm going to show you something cooler first. So right now we have a pip file and a pip file.lock file. Where did those come from? So those were automatically generated when I said pipenv. And the fun thing about the pip file is that it contains all your dependencies. The pip file will contain everything undefined, and pip file.lock will contain everything well-defined. So version number, hashing, and stuff like that. You can edit your pip file. You should never edit your pip file.lock. Those are automatically generated. Now, I have already installed a couple of components, but let's do it again. And say pipenv, and then say install, and say something like IPython. Now, you already have IPython, but IPython will kick in. And here we go into the error messages that I talked about. There's a bug in kind of pipenv. So I'm going to say pipenv install pip version 18.0. It's not actually going to remove the errors, it's just make sure that I can do what I need to do. So the reason why I would use pipenv instead of pip to install stuff is that if you now go into the pip file, so the top part is automatically generated. It just says, where should I get all my sources? So if you have some custom sources, you can do something else. And then you have two sections that we care about, which is packages and dev packages. Packages is your normal installation, and dev packages is the packages that you only use while in developer mode. So you can have one for users and one for the developers, which you will often get into. And then you also have some requires that adds in this case, it just says, hey, you're using version 3.6 of Python. You don't actually need that part. But as you can see, I said just install IPython, and it created this star that just says, I didn't specify version, so any version will do. But for pip, I said, hey, I wanted version 18.0. So it specifies it. Now, if we go into the equivalent, and this is going to be a little bit messy, the pip file lock, it contains a lot of other stuff as well, but it contains the same things that in pip file, but it also contains stuff like hashes. So if I say IPython, here's IPython, here's the hash, here's the version that is being installed on the system. So in this one, I say, I don't care about version, but when I actually install it, there is a version. So now I have snapshots in the file lock that basically says, I know that my system works with this specific version, which is very nice to have when you're going to put things into production, and then suddenly something breaks because some version of some software is not there anymore. And this is something you couldn't do before. Doing this with requirements files and pip freeze is very, very clunky. So very, very nice to have. Anyway, we do have some pip kind of development packages. So you can say install, you can say dev for development, and then say pytest. Huh?
Do you have to be out of the virtual environment to
Nope.
use the pipenv install?
Nope, you don't. I can go out. It's just
you can do it from inside the virtual environment.
if you're inside someone else's virtual environment, there are some flags that defines if you're going to use the virtual environment that you're in versus the one that pip and think you're trying to use. And it will definitely throw out a big warning sign in the beginning. It's like, hey, you're in someone else's virtual environment. What are you trying to do? I'm confused. Something like that. But as long as you're in a folder that contains a pip file, that's actually its reference point. Or if it's in some subfolder below a pip file, it will look downward to see if, hey, where's my pip file? When it finds the pip file, it's like, oh, that's my reference. So you can use this from deep inside your structure. So when I go kind of cd into the source and into my pancakes, and I say pip and shell, it's smart enough to understand that I want to use the one from the pancake level, 2 levels down. It doesn't create a new virtual environment because there is a pip file that it kind of uses. But as you pointed out, you don't need to be in the pipenv in the virtual environment to do the pipenv command. Pipenv command just kind of latches onto wherever you are. So if I say pipenv install and say dev for putting things into the development thing and say pytest, then I think we still get an error. Let's hope not, but no, it went fine. Anyway, something went. Oh yeah, so I did something wrong. So if we now go into our pip file, I'm not going to do the lock file. Now we say that the dev packages now has a new section, which is the pytest. So you have the --dev to always kind of separate between the packages that you use and the things you don't use for your development part. But let's do another one. I talked about coverage. So there's a package called pytest.cov. This one I imagine nobody's heard of before. Yeah, that's what I thought. Okay, coverage depends on something called, well, pytest.cov depends on something called coverage. I think you can see it on the requirements list. It's on install, collection, packages, coverage, and PyTest Cov. So PyTest Cov is just your link between the coverage tool and the PyTest. The reason why I'm going this route is because it's much easier to show you how things are done through PyTest, because doing things through PyTest just makes things a little bit simpler. So cd source and to the pancakes, and then I say PyTest execute, and I say doc test modules, because I want to test kind of see what's going on with that specific file. And then I say cov equals, actually we need to be in the here, I'm going to say source pancakes like that, and I'm going to say source. So okay, first of all, what I did here is that I'm moving down to the roots of my project, because that's where I want to start. I'm pointing to the file that I want to test. I say that, hey, I want to include my doc tests, but I'm doing something new here. I say --cov, which is referring to the coverage, and I do anything coverage in the folder.source. So basically, coverage will cover that folder. And when I run my tests, I don't have PyTest because pip env shell. There we go. And now we can run the command. So it ran the tests, execute.py, one test, and it ran. One test passed. But something new is here. Now we have what was called a coverage report. The coverage report kind of goes through all your files line by line, and when I say line in this case, I'm not talking about line in the statement sense, as in the file line. I'm talking about in the statement sense that Python executed lines. And then it checks, when you ran your tests, was this line executed? Or was this line not executed? And it counts it up, and it creates these statistics. So the init file, which is empty, doesn't have any statements. So it's 0, so you get 100% coverage. But for the execute, there is 5 statements. I think there's like 1 is the function declaration, and then there's 4 inside the function. And as you can see, we missed 2. So what you can do, you can create a report. HTML might be the simplest one. Whoop. Reports. Sorry, I need to quickly find out what the command is for PyTest, because I don't remember that flag. We don't use that flag that often. I am very, very sorry. But we
the equal sign between coverage report and HTML, maybe?
I don't think it matters. I think it uses it might be just kind of cov reports. Ah, there we go. So coverage report HTML written to dir HTML cov. So this is the nice part. So now I have a new folder in my structure. This is automatically generated by the coverage report. And if I now say go, and that's my command for just starting things up, index.html, and let me give it like that. Here's my browser. So the index.html gives me this page. And this will give you a full overview over your project. Since I pointed it at the source directory, that's the only thing it cares about. So every single file that is a Python file that has been executed as part of your test suite is now pointed at. So this is basically the same thing that you saw in the terminal output, but you get a little bit more from the HTML version, because you can click on it. And it will give you line by line which line was run through the tests and which one was not. In this case, this is the reason why I removed my doc test here, is that the branch here, if food item equals pineapple, and everything underneath that is not run, because I don't have a test that tests in that direction. So the coverage basically is telling me, like, that code might be good and all of that, but you're not testing it, which is very, very nice and useful things to do. When you get into stuff like GitHub and doing this, there are tools for automatically creating these reports, which is very, very nice, so you don't have to do it yourself. But the idea that you can go in and see which code is covered by your tools makes world a lot easier. Okay, back to my pancake example. Let's make a test that covers this then. Let's say I like pie. And we're here, and we can do the whole pie test thing again. Actually, no. Let's do this from the outside. I have some shortcuts for doing this. It's my location that is messed up here. Pie test. There we go. And I'm going to remove the report part because I'm not going to use that. Like that. Still, I get 60% because I'm not testing the pineapple part. But this test now failed because I did not have the pie part. I run it again. And now it passes at least. So there's a big difference between passing and having full coverage. So if I now do this and say, hey, pancakes. Well, it crashed, so coverage report is not updated. But if I do like this, what just happened? Oh yeah, sorry, you were quite right. Pineapple, I was thinking too fast there. Pineapples. There we go, and pineapple. And that's incorrect. There we go. Thank you. And here we go. So now two things happen. One thing is my doc test failed because I have the wrong text underneath it. And secondly, and this is an important part, the coverage now increased from 60% to 100%. And that's how you like it. Well, you're never going to get it. For bigger project, you're never going to get 100%. There are a lot of parts that are very, very hard to test that you just like, okay, production, deadlines, more important than getting your 100% coverage. But if you can get things up in the range of 80 and 90, you're very good for big code bases. So it's kind of a good thing to have. So in this case, I increased my coverage by just creating an example that says, hey, what about pineapples? And that basically is my test. That's also the nice things about the documentation style is that, hey, you have your description. And you can do stuff like normal usage, like that. So the default to pancakes, declare love, and everything like that. Okay, we still have time, so we can do other components to this structure. Are you guys familiar with argparse? Parsing. Well, not many of you. Okay, so pancakes, let's see if we can have time to do that as well. I'm going to create two files, parser.py and main.py. Parser, I'm going to say def make parser. I'm going to import a module called argparse. And then say parser equals argparse dot argument parser. Program's gonna declare love, description parameters. Here I declare love for food, and that didn't break up. Well, there we go, almost at least. Okay, parser dot add arguments, and we can add an argument for food item, so we can have that. It is a string. So basically what's going on here, and it's not very complicated, I'm creating an argument parser, basically command line interface. And then I say return parser. That's how easy it is to create a parser with argparse. And as always, test it. Parser equals make parser, and argparse has a specific command, so which is called print help, and then I can say pytest dash dash test, no, doc test modules and the file, and it will print out what's going on when you do the parse. So something to be aware of when you're doing doc test is that if you actually end up doing a double new line, then you're out of the test. It assumes that you're done. So you have to do a special flag for just saying, hey, I want my double new lines to be registered. So in this context, the output will be like these HTML blank line tags. So that's how it registers those. But if you do this on your normal command line, that's what you will get out. Usage, declare love. So basically how your parser will look like. And it's a good way of both kind of showing how your command line argument is going to look like, and kind of give you an overview of what it contents. So basically you're creating your documentation through your tests in a sense. Because now I can just swap that straight into my documentation, kind of my full manual of what I do with my source code, and it's like, okay, so how do you use the parser? Well, it's right there. And if I change something, this test fails. So it kind of forces me to make sure that my documentation is also updated. And the added bonus, it becomes very, very obvious what that function does, because it creates the parser. Okay, let's put it together. A main function. In old Python, there's a file called __ main.__. Is anybody familiar with that? A little bit. Those are not recommended anymore. The new way of doing things is doing things through console scripts. So from parser import make parser, from .execute import declare love. So you want a parser, make parser, very, very simple. So I created the same parser, and then I say namespace equals parser parse args, and then I'm passing it args, which should be none if you're on command line interface. This is for testability, in the sense that when you're running the main function, in a sense, which is here represents the command line interface, then you would be able to pass args your custom arguments from the command line. But if you pass none, then basically that tells the parser that, hey, I want to have that from the actual command line. So if you pass arguments to your parser. Okay, I have a namespace, and now I can do declare love, declare love, and then I give the namespace dot, and you have food item as a parameters, like that. That's it. That's my command line parser, but it doesn't exist in your parser. You have to somehow find where it should be. And how do you do that? Well, if you go out and you go all the way down to your setup file, there's a way of adding something called entry points. You can use entry points for a lot of things. A lot of things that is not really recommended, but you can. But the most trivial way of using it is to use something called console scripts. This console scripts takes a list, and in that list you say what your tool should be called. For example, declare love, and it should have an equal sign, and then you have to point it at, and I don't remember, sorry about that, like that. It's called pancakes dot main, then a colon for pointing at what inside, sorry, main. So very, very straightforward. I didn't give it any complexity. So this tells setup.py that you have a function inside your project somewhere. This is the location of the function that I'm interested in to use as a command line interface. And I want the command line interface to have this name. And I know my typing is kind of horrible because I think declare is written very wrong, and I've been very consistent in it, but I don't care anymore. Anyway, so one thing that you guys maybe didn't notice is that earlier on this talk, I said that I'm going to use develop instead of install. And you guys, I haven't seen develop before. So why did I do the develop part? Because I've used it many times now without you guys noticing. Have you noticed that I haven't reinstalled the software? That I can now just do IPython and from pancakes execute declare love, and I can say declare love pineapple. No one likes pineapples. So despite the fact that installation was one of the first things I did, long before the feature with pineapple came up, it's updated. It has a live version of your command. So when you do setup.py install, it takes what you have in your directory installation and what you want to install, and it copies it over to your installation. Which means that if you make a change later, those changes won't be reflected into your developer mode. So what you're going to end up doing, which I did a lot during my master's degree, is that I keep on reinstalling. I make a change, I reinstall. I make a change, I reinstall. PyTest gets a little around this in its own because it has some tricks up its sleeve to try to avoid this. But for normal, just executing your code, you keep on reinstalling all the time. By doing develop, you don't. It creates a link directly back to your installation directory, which means that any changes you make will automatically be reflected into your code. That's why I can ignore those problems. Now, second part is now, however, we can't get around it because I made a change to setup.py, and reflection in setup.py is not reflected by setup tools. So now I have to do Python setup.py, and now I do a develop again. And I can't do my syntax because it's a dictionary, and this should be a colon. There we go. Here you go. It should actually says what the give me 2 seconds. Can we see it? No. Okay. Declare. Yeah. So yeah, it's kind of my E that comes in there, my complete typo. But as long as I'm in my virtual environment now, I now have a command line tool, something that just pops up because I installed it. I told setup.py I wanted a new command line tool. And I need a food item, yeah, because it's requirement. I didn't give it a default value. So I can say pie, I love pie, and I can say pineapple. No one likes pineapples. So basically I created an API, is usually what it's called, when you kind of create code that can be reused as a library, Python code. That's what basically all of you are doing the second you're getting into the setup.py. But as soon as you create these console scripts, then you're getting into the world of creating command line interfaces. And if you can make good code, you try to balance it. If you need both type of features, then it's very nice to have code that is reusable in the sense that you have both the command line interface and the API available at your fingertips. And you don't want to do things double, and you definitely don't want to create your own command line interface. So this is how you do it. And then you get into pancakes again. We go back into the main. Now, as I noted, as long as I don't pass anything to args and let it be none, then it takes things from command line interface. That's why it works, because args, in a sense, will never be filled with any values. So you don't actually need any arguments. It's not dependent on that. The console script will call a function without any arguments, period. The reason why the command line arguments get parsed anyway is the fact that argparse gets its value from sys.argv, which I imagine you guys are very familiar with. But you shouldn't really be touching sys.argv yourself, ever actually. This is how you should be doing it, because this kind of pushes this away to somebody else to do your job for you. And that's kind of the rule of thumb of making production code, is if somebody has done it before you properly, let them maintain it, because you don't want to maintain things yourself. If you can cut your maintenance burden a little bit, you do it. So here we have a full-on command line interface, and I did not import sys at all. And I imagine none of you guys have seen a command line script created like this in Python without importing sys, which is kind of your 101 of how to do these type of things. And but I did have this arg dot equals none. And the reason for that is that now my command line interface is also testable. I can do, like I've always done, and say stuff like main. Now, command line interfaces follows the sys.argv structure, obviously. So I have to do stuff like just give it pineapple, for example, as a kind of position in a list, because that's how shell works. Simply, it takes a string, finds all the spaces that is not cancelled out, split them up, creates a list, and that's your sys.argv arguments. That's basically what it does. And then element 0 is the name of the program. So what you will get in this context is, when you parse args, is that you just create the value of the arguments that you want to send to it. And if we now go down, sorry, errors, but PyTest, doctest module. There we go. Now, another thing I'm going to do, oops, sorry, instead of testing the file, I'm going to test the folder. Now, when I test the folder instead of the file, it will take every single file and every single file in the subfolder. So I can actually do it even more. So in this case, it ran the test for all different 4 files. But if I want to do it for everything, well, this is the same thing in this context. But if you have more than one module in your source folder, you can just say source. This is the normal way of doing it. And keep in mind, if you have a test folder in addition, just add that too. So you can have one command that says, hey, I want to do all my tests. But if you're nitty-gritting with small details, you can get in and start pointing at the files that you want to test right now, because you're often getting into the point where this is where I'm working, this is where I'm going to run my quick tests, and when you're done, you run your big tests, just the whole shebang. And you get a lot of tests. I think my project that I'm working on now has over 1,500 different tests. So it takes about 10 minutes to run everything, which is quite a bit. But anyway, it failed. It failed because I ran my main program, and I got a results back. So despite the fact that this is a command line interface, it still behaves like a Python program. Yeah, that's wrong. The wrong is that should be P here. There we go. There we go. No one likes pineapples. I can't spell. It's apples with an E-L instead of L-E. Nobody's pointing it out. I'm just laughing inside of me, I'm assuming. No, I'm joking. Anyway. Yeah, I didn't want to disturb me. My point still stands, though, despite the fact that I clearly don't know how to write on the fly. But anyway, the nice thing here, the point I'm trying to make, is that despite the fact that this is a command line interface, and your mind might just be going straight to the idea like, hey, maybe I should make some command line interface tests on the bash prompt. Don't. Just put it into Python. Now, there are a way of kind of getting into the world of doing construction and deconstruction of your tests. I don't know if you guys have been into this type of stuff. No. So more advanced tests often require you to create some kind of environment where all your files and all your stuff is available, which is very, very important, which gets a little more complicated when you do PyTests, but still possible. And then you have to have extra module for doing it. But 99% of the time, this is enough. This gives you a lot. And it's also very easy to read. So I have like 30 different structures that are basically like this throughout my code base. They're basically, as in you have some libraries that does some kind of heavy lifting math-wise of doing the math stuff and type of things. But you import those in. You don't do the heavy lifting in these three functions, in these three files. In these three files, you do three things. You do execute, you do main, and you do parser. And in one, you create the parser and say, hey, how does that work? Well, that was not the parser. This is the parser. In one, you do the execution where you actually do the content. Typically, if there's a lot there, you would import from some completely different module and say, hey, do this. So it becomes like a thin wrapper. And then lastly, you create the command line interface on top of it that just say, hey, this is how things will look like when you create the command line interface, putting it all together. And then you put logging into all of it and yada, yada, yada. Okay, that was that. That was my little talk about code in production. I hope that was enjoyable. Thank you.
Thanks.
Are there any questions? Nope. Okay, then I'll stop recording.
That code there, the sample code, is it available on the IT machine?
If you send me the code, I can.
Then yes.